My dear students, we were going to discuss about the haloalkane and haloarenes. So, hope so you remember the objectives of this chapter. First of all, this chapter includes general classification, general introduction. It means about some haloalkanes and haloarenes where they can be used in our daily life, and then classification of haloalkanes and haloarenes, followed by nomenclature. Nomenclature comes first to classification. Why? It is because after naming the compounds of organic chemistry, we can classify them easily. So we have to know the nomenclature of the compounds. But generally the classification of the haloalkane and haloarenes are given in our NCERT book. We can follow the simple or common rules on all the organic compounds in our organic chemistry, including all the 4 chapters like haloalkane, haloarene, alcohol, phenols, ethers, aldehyde, ketones, carboxylic acids, amines, and other nitrogen containing compounds. And after nomenclature, we have to discuss methods of preparation, and then chemical reactions, and stereochemistry of these reactions, how they can be changes into one form to another or their transformation. We will discuss in detail with the proper mechanisms like nucleophilic substitution, unimolecular, bimolecular, retention, inversion of configuration, racemic mixture, racemization, and all these general terms we will discuss. And after that, polyhalogen compound. Polyhalogen compound. So let us start with the chapter. So generally, there is a replacement of hydrogen atom in aliphatic or aromatic hydrocarbon. Aliphatic, it means the straight chain compound, and aromatic is the cyclic compound. Cyclic or the compounds containing 4n plus 2 pi electrons. 4n plus 2 pi electrons following the Huckel rule. So simply the aromatic and aliphatic, suppose CH3, CH2, CH3, this is aliphatic and this is benzene, it is aromatic. So formula of benzene C6H6. So suppose all the corners containing carbon atoms and each carbon is attached with one hydrogen atom. Each carbon atom attached with one hydrogen atom, and all the 6 carbon atoms are conjugated. All the carbon atoms are present in conjugated system. Conjugated system is a system in which carbon is connected to the other carbon with double followed by single and then double bond. So there is an alternate double bond present between the carbon atoms of the given compound. Simply the C6H6 is the benzene, is aromatic in nature, and this is propane, CH3, CH2, CH3, this is propane, this is aliphatic in nature. So suppose if we are replacing one hydrogen atom of this CH3 group, one hydrogen atom from this CH3 group with the halogen atom, then it will be CH3, CH2, CH2, Cl. So it will get changes into haloalkane. Name of this haloalkane is chloropropane. Chloropropane. In the same way, this cyclic ring having carbon atom on the corners attached with hydrogen atoms, and if this hydrogen atom is replaced with halogen atom, it will be chlorobenzene. But you should know about the mechanism of this replacement or displacement, or most appropriate word for this displacement is a substitution. Most appropriate word for this displacement is substitution. It is a displacement or the mutual displacement. This substitution can be possible by homolytic cleavage, or it can be possible with heterolytic cleavage. Homolytic cleavage involves the breakdown of a covalent bond by equal distribution of electron. Suppose this covalent bond is formed by the mutual sharing of the electrons of the two bonded atoms, and these two bonded atoms are the chlorine atoms. They can use their 7th electron because halogen atom contains 7 valence electrons. So the 7th electron is shared with the other valence electron of the bonded atom, and it will form the covalent bond. This is a covalent bond. So while breaking this covalent bond, there will be the equal distribution of these two bonded electrons. One is on this atom and second one is on the other atom. So there is a equal distribution of the breakdown of the covalent bond gives homolytic cleavage, and homolytic cleavage generates the free radicals. Homolytic cleavage generates free radical. Must remember the point. But in case of heterolytic cleavage, hetero means the different or unequal distribution of the electrons. Suppose we have H2 molecule and these two bonded electrons shifted towards a single atom or shifted towards this hydrogen atom, then it will carry negative charge and this will carry positive charge. So there is the unequal distribution of the electrons of the bonded atom and the formation of the cation and anion. Cation and anion takes place. So these two ions can generate two poles. So the polarity is there. And it will be the product of heterolytic cleavage. So the formation of ion can be possible with heterolytic cleavage and formation of ions in heterolytic cleavage. Suppose we are talking about substitution. CH3CH2CH3 is the propane and addition of Cl2. Simply one other definition you can memorize from here. Addition of halogen is halogenation also. Addition is a process or addition of halogen is halogenation. Breakdown of this Cl2 via free radical mechanism, and this carbon contains hydrogen atom. This hydrogen atom and carbon atom free radical can be displaced by this chlorine atom. So hydrogen and chlorine combines to form hydrogen chloride, and this CH3 CH2 CH2 Cl CH3 CH2 as it is and CH2 Cl can be formed. So it can be possible with free radical mechanism. Suppose we are adding halogen or the halogenation to aromatic compound or aromatic hydrocarbon. Simply carbon and hydrogens are there, so it is a aromatic hydrocarbon. Simple. Here this H positive is replaced with chlorine, and this chlorine positive and this chlorine positive this chlorine positive is a electrophile. This will be on the position of this displaced H positive ion. So the desired product will be chlorobenzene. Simply here is the displacement of the electrophile. So this displacement is the electrophilic displacement or electrophilic substitution. This displacement is the electrophilic substitution proceed via heterolytic cleavage. So these are the some simple terms or the terminology like homolytic cleavage, heterolytic cleavage, displacement or the substitution, electrophilic, nucleophilic, generation of electrophile, generation of ions like cations and anions. These all terms are related to the chapter which we will discuss in detail in this chapter to clear all the concepts. Hope so this point will be clear to you. Now the replacement of hydrogen atom in an aliphatic or aromatic hydrocarbon by halogen atom results in the formation of alkyl halide. Alkyl halide is a common name and haloalkane is the IUPAC name. IUPAC name is the most accepted name of the organic compounds. Alkyl halide is the common or the trivial name. And aryl halide is the common name of haloarenes, or these are the aromatic compounds. They can be formed by the displacement of hydrogen atom to these hydrocarbon. It can be aliphatic or aromatic. If there is a displacement of hydrogen from aromatic, the formation of aryl halides or haloarene. If there is a displacement of hydrogen atom from aliphatic hydrocarbon, then there is the formation of haloalkane or alkyl halide. Now this is a simple haloalkane, or this is formed from CH4. Now this CH4 is like this. Carbon is attached with all the hydrogen atom by single covalent bond, and these single covalent bond shows the hybridization of carbon atom. And if carbon atom is bonded to the other carbon atom or the monovalent atoms, monovalent means if the atom or the bonded atom has only one electron, that is shared with the carbon atom. So the monovalent atom is hydrogen atom here. So we can say the hybridization of carbon is sp3. But if we talk about benzene, there are 3 double bonds on alternate positions. So the carbon in benzene, or each carbon in benzene, is sp2 hybridized. Now the point from here is, out of the sp3 or sp2 hybridized carbon, which one is more electronegative? Point to remember here is the electronegativity of the carbon regarding hybridization of the atom. Now electronegativity is directly related to the percentage of S character. Electronegativity is related to the percentage of S character. Greater the S character, greater is the electronegativity. So electronegativity is directly related to the S character. So percentage of S character in sp2 is greater comparative to sp3 hybridization. So sp2 hybridized carbon atom is more electronegative. where there is the less chances of displacement of hydrogen compared to the alkyl halide. Alkyl halide has the carbon atom which is sp3 hybridized. So there is the difference in haloalkane and haloarene on the basis of hybridization, that is sp2 hybrid carbon in case of the haloarene and sp3 hybridized carbon atom in sp3 hybridized carbon atom in haloalkane or in aliphatic hydrocarbons. Now the point, haloalkane contains halogen atom attached to sp3 hybridized carbon atom of the alkyl group, whereas haloarenes contain halogen atom attached to sp2 hybridized carbon atom in case of aryl group. And these haloalkanes and haloarenes containing halogen atoms in these organic compounds present in our daily life or in our nature are clinically useful. So there are many wide applications in industry, in our day-to-day life. Suppose they are used as solvents in non-polar compounds. Non-polar compounds or the solvents. Solvent word is related to the solution, and that is prepared by the addition of solute and solvent. Solute is in small quantity and solvent is in larger quantity. Now the solvent which contains ions is polar, and the solvent which do not have ions is regarded as non-polar solvent. But the question will be in your mind, how non-polar solvents dissolve the other solutes and other substances. So there is a hypothesis or the concept that is like dissolve like. This concept is similar to the friendship. We will find our friends as we are. Simple. So like dissolve like. A polar solvent dissolves polar components and non-polar solvents dissolves non-polar components. So this concept is applied to the solutions in case of the preparation of other organic compounds from the starting material. So they are used as solvents for non-polar compounds and as starting materials for the synthesis of other organic compounds. After that, some most accepted compounds are the chloramphenicol. Chloramphenicol is a compound which is made up of chlorine, Now chlorine is halogen here, that can be represented by X generally. It can be fluorine, chlorine, bromine and iodine, and these elements are from 17th group of the periodic table. So the chlorine containing antibiotic, this chloramphenicol is an antibiotic. This point is important from here as per our MCQ of NEET exam. And it is very effective in the treatment of typhoid fever. Next point is related to where it can be used or which disease can be cured by chloramphenicol. Simply, question can be, name the chlorine containing antibiotic, that is chloramphenicol. Name the halogen compound which is effective against typhoid fever, that is chloramphenicol. Now the chloramphenicol contains the element or the halogen. So it can be remembered by chlorine started with chlora. It means directly related to the half of the letters of this chlorine atom. So chlorine containing antibiotic chloramphenicol is effective against typhoid fever. Must remember these two questions that can be prepared from this text. Now the second is thyroxine hormone is secreted by thyroid gland in our body. And this thyroxine hormone is secreted by thyroid gland. It contains iodine. If there is the proper amount of iodine is secreted in our body, there is no problem. And if there is the deficiency of this element in our body, it will causes goiter. This disease is related to which part of our body? Question. It is related to the swelling of the throat or the neck region. Why it will be? Then it will be possible with the deficiency or the insufficient amount of the secretion of thyroxine that regulates the iodine in our body. If there is a deficiency of iodine in our body, then what should be advisable? It is advised to take iodized salt by doctors to maintain the concentration of iodine in our body. If there is a hyper or hypo secretion of thyroxine in our body. Hope so this point will be clear. Very important point to remember as per our upcoming exam. Now coming towards the next compound, that is halothane. Halo means halogen containing compound. This halothane is used as an anesthetic. एनेस्थेसिया के लिए यूज़ किया जाता है ड्यूरिंग सर्जरी. And then fluorinated compounds considered as potential blood substitutes in surgery. हालांकि fluorinated compounds are very dangerous to be used directly, but here certain fully fluorinated compounds are being considered as potential blood substitutes in surgery. They are very effective. So generally 4 to 5 halogen compounds that we have discussed in our day-to-day life, or they can be used clinically as anesthetic or during inactive secretion of the proper glands in our body. Sometimes we can use some of the compounds as antibiotic, or so many application, or the wide application of these halogen compounds in our day-to-day life. So in this unit we will study some important methods of preparation, how they can prepare, how we can prepare these compounds, and what are their physical and chemical properties, and how they can be used as organohalogen compounds in our life or related to biological purpose. Hope so this introduction will be clear to all of you. So must remember all these important points related to this